So then I think we can start. Good afternoon. Welcome everyone. It's nice to see so many faces. Alexandra cannot be here today, so she asked me to start and introduce Katie Winkle, our guest. So she will talk today about the robot colleague. Katie is an assistant professor at the Department for Information Technology at Uppsala University, so she enjoys that it's not so gray here, like in Sweden at the moment. Well, apparently
Sweden is worse.
Sweden, she's used to worse. And she is studying social robots. She is part of the Human-Machine Interaction Lab, and she was a postdoctoral fellow before at the KTH, Royal Institute of Technology in Stockholm, and completed her PhD in robotics in Bristol. So it's very nice to have you here, talking about all the applications in human-robot interaction. She's designing, for example, social robots for children that may help in education, robots in healthcare. So you will talk a lot about these potential applications. We met at the Jacobs conference because she's a research fellow there. And so, yeah, it's very nice to have you here.
Thank you.
Let's start with your talk.
All right, thank you. Yeah, thanks for having me. So I'm going to talk about the robot colleague and specifically about in-situ machine learning approaches for creating robot colleagues in healthcare and education, as Janine said. But to give some background or some sort of framing, I mostly work with what we call socially assistive robots. So we can argue about what's a robot and we can argue about what's a social robot. Typically, when people talk about social robots, they mean something like Pepper here. So something that leverages either anthropomorphic or zoomorphic features. But as I said, people give their robot vacuum cleaners names and don't want to put them in cupboards. So how we decide what is social is hard. But in general, the idea with these robots is that they're supposed to provide some assistive function. So I'm not really interested in robots that are just for entertainment. And even though I'm an engineer by background, I'm not really interested anymore in physically assistive systems. I'm really interested in this social interaction as assistance. So typical examples you see is things like guiding and encouraging exercise, whether that's educational exercises like cognitive exercises, or whether that's health related. So it could be in the picture you have a robot helping you to work out. But here the social interaction is critical. So we're talking about robots as motivational companions. So when we want to think about designing robots for these applications, an obvious place to start is to look at how humans do this. This is one of my old PhD colleagues who I got to put on a treadmill for my PhD work. So, providing effective social assistance isn't easy, right? That's why we have experts in physio or in fitness. People who know how to do this well, they know how and when to be serious, when to tell you what to do, when to explain to you, how to explain to you. But then they also know when to sort of chill out a little bit, when to have a bit more sort of social interaction, and that this is important in getting the client engaged, getting the client motivated. And they really know when to switch, because actually if you make the switch to this from this at the wrong time, you can completely screw up the social interaction and kind of damage your credibility. And when to do this varies for each individual person you're working with. So there's really a lot of sort of situational intelligence that's happening in this interaction. So when we think about robots then, we have this technical challenge, how on earth would we start to replicate this kind of complex, tacit and situational intelligence that we see in someone like Don, the fitness instructor. So that was Don in the picture. How can we try to build an AI-based system that can come close to that? And then on the more social side, how do we design a robot that is acceptable, credible, that actually gets people engaged, people that have really mixed responses to social robots in terms of whether they like the robot, whether they just find it uncanny and weird. So there's a lot of questions there about how we design for acceptance and acceptability. And then on top of the broad social challenge, we also have, the ethical challenge. I mean, this is a really meaningful interaction for both people. I mean, Don gets a lot of work satisfaction from, delivering a good service to his client. And for the client, I mean, it's really meaningful that he has this human interaction that helps him exercise and motivate. So these are some of the challenges that I try to tackle simultaneously in my work by thinking about how we can build robots in a way that from the beginning kind of has these questions in mind. So when we're thinking about these questions, a lot of people will talk about participatory design as a really sensible way to start. So participatory design is just basically talking to your users. And during my PhD, that's where I started. So I was like, okay, I want to design a motivational robot fitness coach. Where do I start? Well, I spoke to a bunch of physio and speech therapists and tried to ask them like, okay, well, firstly, I observed them. I asked them to try and explain to me like, what is it that your clients struggle with in terms of their self-practice and their engagement with their practice? How do you motivate them? How does that vary across patient 1 versus patient 2 or client 1 or client 2? And this was really great for getting ideas of like, okay, how should the robot behave? But not so much when and how in terms of the technical side, but really just, okay, this is what it looks like to motivate someone. The robot should ask them if they've had a good day. The robot should be listening to whether they are like happy in their voice or sad in their voice. These are the kind of things that the therapists would say. And that's really great for like this social side. I mean, participatory design is really useful for trying to understand at a high level, okay, how can we make these robots do something useful? What would useful look like? And what would acceptable look like? And sort of actually on the robot behaviors, how they should look. But participatory design really doesn't help us with this more technical challenge. I tried to do the observational stuff. So a classic kind of AI approach would be to video interactions like this, and then somehow try to code what's going on. And then maybe you can try to learn some sort of interaction model from that. But actually, this just wasn't really feasible for the situations that I was looking at. And I'm not convinced that deep learning is really the way to go for these really, really, let's say, like social interactions that are very, very context specific. So we still have this technical challenge of how to get this sort of tacit, it's really that sort of intangible situational bit. If you speak to a therapist and you can even show them something they did and they say, okay, why did you in that moment tell this guy that he should work harder and not tell him like, great job? They will say, oh, it just felt right. I could feel that he was slacking. It just, they talk about intuition. And so it's really hard from an AI perspective to try to think how we would replicate that. So in my PhD, I tried to come up with an approach that would sort of tackle the technical challenge, but still with the same ideas of participatory design. So some colleagues in robotics around the same time were working with in-situ machine learning. So this idea that you basically capture your machine learning data in situ in real time and then progressively learn a policy from that. So I wanted to combine that idea with typical participatory design, and then we put it together in this method that we made a nice acronym, LEADER, and then made it backwards to if it's led by experts, automation, and design of robots. But basically, this is basically participatory automation, I would say. So here, rather than sort of going away and doing a focus group and identifying how the robot should work, and then going back to the lab and trying to implement it, and then coming back to talk to the experts again, the idea is here to try and do it together. So the process goes like this. You go and find yourself a domain expert, in my case, a fitness instructor that I'll show you in a minute. You work with them to identify what the robot should do, so what should be the robot's action space. You also work with them to co-design the input space. So what are the input features that my robot needs to be thinking about when it's deciding how to use the robot action space that we've designed together. Then you actually just put that in the world and have the instructor teach it how to use that action space. Over time, it starts learning, and then it can start making suggestions to the fitness instructor, and then he can accept or reject those, so you have another little bit of reinforcement learning on top. And then from there, you can move towards autonomy, or at least that's the theory. So in my PhD, this is how that looked like. So here, the overall idea was, originally I started off thinking about this robots for therapy, how to engage people in their exercises when the therapist's not around. For the final project of my PhD, we moved towards just a more simple running program, just because it's hard to do ethically to do stuff with patients. So in this case, we agreed that, so with Don, the fitness instructor, we agreed that the job of the robot was going to be to guide people through the Couch to 5K program. So that's a podcast-based program in the UK from the National Health Service. Basically, it builds you up to running 5 kilometers, and it's super boring, right? Because the week one, it's like walk for a minute, run for a minute, walk for a minute. So we thought it was a good proxy for these kind of rehabilitative exercises that people don't want to do. So this was our starting point. So we said, okay, working closely with the fitness instructor who we employed properly to work on this with us. And we said, okay, what does the robot need to be able to do? What input data does the robot need access to? And of course, we actually put Don on the treadmill. I went on the treadmill, he went on the treadmill. We really tried to role play how it felt like to make sure that the actions he was coming up with still felt right once we put them on the robot. He'd never worked with a robot before, of course, so there was a big learning process of role playing this out. And of course, the input space was a negotiation because he said things like, oh, I would love to know thermally the data of what temperature they are. And I was like, yeah, no, we don't have those sensors. So can we use heart rate instead? There was some negotiation at least. But we tried to build an input space that was in the overlap of what sensors we had, what was feasible to implement, and what he thought was relevant. Then, that's one thing, but we also talked quite generally, where does the robot go in the gym? Where does he go with relation to the robot? How much are we going to explain to the participants? Because we're interested in understanding really the interaction with the robot, but we don't want to hide the instructor away. So this was also part of the negotiation process. We also talked about where does the role of the robot start and stop? So when a participant comes to the gym, Don says hello and maybe asks how they're doing as usual, but then he hands over to the robot. And we saw some emergent behavior here that I'll talk about at the end that was also very interesting. And then, of course, not only did we have the actual robot design, but we also wanted to make sure that this control interface through which he was going to be able to teach the robot, let's say, we also co-designed that together because we have to make sure it's useful from a UX perspective. We have to make sure it's easy for him to understand how to quickly execute things because he's really watching what's happening here and telling the robot what to do on that basis. So it needs to be fast so that he can react situationally to what's happening. So this is what it looks like once it's set up. So now we have one of our participants on the treadmill. Don is monitoring the teaching interface, as you see there. And the idea is he's watching what's happening and then would tell the robot what to do by pressing the buttons on the tablet. After some time, the robot starts to make suggestions based on what it's learning. So from a technical perspective, this wasn't anything fancy. This was a k-nearest neighbors clustering algorithm. It's super basic. It retrained at the end of every session, which is how it updated. But here you can see how it looks when it starts suggesting things. So in the top one, it's suggesting a praise action. And then there's a red, a circle around that's getting smaller. The red is overtaking the green. So it has, the instructor has 10 seconds to decide, yes, do that action now, good. In which case there's a positive reinforcement signal, or no, that's bad, don't do that action, and then it gets cancelled and nothing happens. And down here, so this is on the top, you can see basically the additional actions that are on top of the basic instructions. So the program still has to tell you, okay, now it's time to walk for a minute, now it's time to run for a minute. And there, the only thing the instructor could change was the style of that action. So positive, neutral, challenging, or sympathetic, I think. So basically, again, here the system is saying, okay, in this bottom picture, the next program action is walk, and I think you should do that in a positive way, and then the instructor could say, no, actually, you should do it in a challenging way or something else. The instructor also wrote all of the dialogue for the robot, so this was pre-LLM times. So actually, he just wrote a database of fixed phrases that the robot cycled through as the time went on. And so we put this into the university gym. So the university gym is normally closed over the summer. So we got permission to install this in the gym for the 3-month summer period. We had 10 participants, one of whom dropped out. So we still had 9 people who came 2 to 3 times a week for this 3-month period to finish the NHS program. In total, that was roughly 230 odd sessions, around 150 of which we used to teach the robot. So it's really important to say that these numbers are kind of arbitrary. We just wanted to test, we tried to train the robot for as long as possible, whilst still allowing plenty of time to test the resulting autonomous system. So I can't say anything about whether we could have trained it for less time, but we did it for about 150 sessions. And then we had about 30 sessions where we were testing the robot as taught by the instructor. And then we also had, I guess, some sort of control condition where we asked the instructor to write heuristics, some old school, if this, then that instructions that used the same action space and input space to try and basically make a comment on whether this fancy machine learning approach was worth doing at all. Okay, so it worked to some extent. So let me explain this graph a little bit. So this is a normalized action distribution across all of those number of sessions. So it really varies how many sessions and how many actions are represented here. But the key things to note, so where you can see MLA, that's the robot acting autonomous after it had been trained. MLS is the robot acting supervised, so ultimately the instructor regaining control. For the autonomous sessions, we basically just told the instructor not to press any buttons anymore and made sure he did that, unless we didn't just cut the link because he was still ethically responsible to, like, the robot should not tell someone to speed up 15 times in a row. This would be unhealthy. So he was still connected in case of something like that, but nothing like that happened. So we say that those are autonomous. And then the H ones, that's the heuristic-based system. And then LB and MR are two different participants who had very different needs in terms of their exercise. So the first thing to notice in both cases, if we compare the MLS to the MLA, you can see that the autonomous system, let's say, replicated to some extent the action distribution of the supervised system. Again, I'm not really making any strong claims here because this is actually really hard to analyze, because actually what's very important is that you do the right action at the right time, not just in sum, on average, the correct action, let's say. But at least this says something about how these systems compared. The other important thing looking at the MLA and the MLS is that they are quite different for LB and MR. So to give some context, LB was someone who let's say was not a frequent gym goer. For him, this Couch to 5K program was very genuine. He was really one of the people who the system was targeting, the podcast targets. MR was already running, so for her it was less of a challenge, and you can kind of see that in the way the actions play out. So MR tends to have a few more praise actions. LB has a bit more challenging actions. So the instructor, when we talked about it afterwards, he felt that LB needed a bit more challenge, let's say. But then on the heuristic system, basically the robot basically produces the same policy for both of them, or the same action distribution for both of them. And basically you can also see that the heuristic system uses way less of the actions. So it uses the challenge, the maintain, the sympathize, and the check PRE. PRE is perceived rate of exertion. They ask how you're feeling. The main reason there is that when we worked through it with the instructor, and we did iterate on these heuristics, so I don't want to suggest that we really made the heuristics bad on purpose. We tried to really come up with something sensible. But it's just really hard to write a heuristic for humor in an exercise context, right? Because if you say a joke at the wrong time, again, it just can completely destroy the person's confidence, for example. So the heuristics system ended up being pretty basic, even though we tried to, we iterated halfway through, we tested, and yeah. So that's just from the action distribution point of view. What's also interesting is that at the point that we, let's say, turned on autonomous mode and stopped Don from controlling the system, only 2 participants noticed a change. We didn't announce it, so I mean, there's loads of arguments here. You could say they were just super bored already and they didn't notice, maybe they weren't paying attention to the robot anymore. But I think it's quite interesting that 2 out of 9 felt a difference on the day that we went into autonomous mode, let's say. Of course, we also asked people how they experienced this. We had a bunch of social type measures, although I'm not really making any bold claims here. I mean, it's 9 people. It's hard to run these big long-term studies. We're pretty happy that 9 out of 10 people stayed all the way through. I think that's quite impressive. We're quite happy. And we saw people generally being positive. Out of the 9, there was 1 who hated it, and that's fine too. She stuck with it to the end, and her final reflection was like, yeah, I only want to work with humans now. That's okay. I'm not saying everyone has to have a robot, so that's also valuable. But for many of them, they really liked that they had this kind of robot companion. We also tried to drill down a little bit onto the instructor. I mean, for me, this was probably one of the most fascinating things to watch, was how Don's conceptualization of the robot came to be shaped, I guess, through this process. So he very much felt that this was like a colleague. In particular, I asked him if it was a mini-me, right? He trained it, he designed the actions. He was like, no, it's definitely its own thing, its own person. He would say things like, oh yeah, Pepper did this action and I wouldn't have done that, but yeah, it was totally right for Pepper. And I was like, hello, you're teaching the robot. Like, I don't understand how you're teaching it to be something that's not you. But anyway, it was really, really interesting to watch. And I mentioned earlier about this like emergent synergy. So we had planned the experiment over these 3 months, and each session where a participant, participants booked which session they wanted. Each session was 45 minutes, but by the end of the program, the overlap between participants was starting to get a bit tight, because by the end of the program, you're running the full 5K, and for some people that takes like 30 minutes, 35 minutes. And we got into a situation where the next person would, Don said, look, now participants are running for longer. I want them to do some stretches before they leave. I think it's important for their like health and safety. So I actually left the gym most of the time when this was up and running. I would go there first thing in the morning, make sure it was okay, and the lab was just across from the gym, so he would just call me if there was a problem. And I went back one of the days, and he had started like implementing this system where, as a new participant came, he would just get them warming up autonomously with the robot while he was doing stretches with one of the other participants at the back. So for me, this was a really nice emergent synergy of like the kind of human-robot teaming I think it would be nice to aim for in these settings. So yeah, this was really nice. And then finally, what was also nice from the participants' point of view is that they were able to reflect on the combination of Pepper and Don. So, a lot of them referred to the fact that, yeah, it's nice that Pepper is the one right next to the treadmill, but I'm happy that Don is in the background. I know they still valued the social interaction with him. They also felt sort of secure and safe, knowing that there was still a human in the vicinity who could make sure that they weren't doing anything unhealthy. So for me, I really like how this ended up playing out in ways that I didn't necessarily expect in terms of this human-robot-human interaction, and how that kind of emerged during this process. In fact, I liked it so much that I'm not sure I'm actually interested in building fully autonomous robots anymore. This whole process, that was really the start goal, was to kind of simultaneously deliver on this technical challenge of creating this in like situational intelligence, but also the ethical challenge of making sure there was an expert involved and like that was going to be accepted by people. But having seen this, like, I'm not really sure anymore if I want the robot to be fully autonomous. Like, maybe a next iteration of this process could be a way to deliver on, there's a lot of buzz right now in AI ethics around like human in the loop and keeping people fulfilled and all of these things. So I'm quite interested in what a next iteration of this would look like, and how we could use that to create an experience that's not just good for the participants and leverages some sort of smart semi-automation like what we had, but never really gets rid of the human and keeps the human involved. So maybe you imagine multiple robots, a robot at each treadmill, and then Don has some sort of overseeing system. But I think it's really important, like, these photos are from Don's Instagram when the study finished. This was obviously an N=1 case study, but I think I would really think harder next time about the instructor's experience also. Like, what does it mean to design for fulfilling meaningful work with robots? Okay, and then Janine also mentioned that I do stuff with kids. So during my postdoc and some of the work I will do now with the Jacobs Foundation, basically said, okay, can we take this whole process and do the same thing with kids? So kids as our design experts, domain experts. And in this case, we explored the idea of a group assistant robot. So the motivation for this switch to kids was sort of twofold, and for this specific application. Firstly, there's been some very interesting work in human-robot interaction literature that really does suggest that robots can significantly impact group dynamics. They can impact how we talk to each other, who talks for how long, and kind of how this can play out. In general, most of these works tend to go and look at psychology literature or social science literature and say, okay, we have this phenomena in psychology, we have this observation that if you do this, a human responds this way, and then you can program the robot to replicate that and see if it works. Often something happens, but often not exactly the way that you might think. So sometimes you see either like opposite effects from what you might think, or you see unexpected effects. Maybe we shouldn't be like trying to replicate human interaction with a robot that is just a sort of poor proxy for a human. Actually, robots tend to be interacted with a bit differently. So our idea here was basically to say, okay, rather than just go and like pull from the literature and design a robot ourselves, maybe children can do better at helping us identify how a robot could support their group work. So this was the kind of groups and robots side. There was also kind of, again, this idea about what it should look like to involve children quite seriously in the design of technologies for their use. So the UNICEF policy guidance that came out in 2021 makes a very strong case for this. If you're following along the kind of EU AI Act, trustworthiness and human in the loop, it's all sort of really present in these discussions. So there was also a question of, okay, children should be involved in the design of technology for their use. There's also a big discussion about how we need to educate young people around how AI-based systems work, how they collect and use data about them. I think we could all understand that better, but especially for children who are growing up with these systems, understanding how such systems might influence their behavior. And I think the method that I posed, this kind of very participatory design and automation, maybe ticks both boxes, because if you're so integrated in the design process, you really see for yourself, right, that the robot starts to replicate the things that you tell it. You also can really see the input data to some extent, or at least you could with more iterations of the tablet interface, for example. So this was kind of our starting point. So there are a bunch of questions here that we were interested in, and this work was super exploratory because people have done participatory design in robots with kids and young people, but not really so much this kind of automation approach. So of course, first of all, we can just ask, okay, how do young people imagine this concept of a group robot assistant or a social robot group assistant? Do young people make for good robot teachers, right? I was hopeful, but we kind of were fully aware that they might just mess around that entire time and they might teach the robot bad things. I don't know if any of you are familiar with Microsoft Tay, but Microsoft put this chatbot on Twitter a couple of years ago and then had to take it down because within 24 hours it was like sexist, anti-Semitic, it was just awful. So, there's always this hesitation of like, if you give people control of a robot, will they do stupid stuff? And then finally, this reflection on, okay, this whole process, if they know that it's their friend that's controlling the robot or teaching the robot, how does that potentially influence their ideas about whether the robot is a social agent or is it a proxy for someone else? I mean, these are all really complicated questions, but we were interested in starting to explore some of these. So we ran a 2-week, we really did call it a summer school research study, and we were very open with the kids about that, and I'll explain a bit more of that in a minute. But this was 2 weeks in the summer. We held it at the university, so I mean our population was a bit biased because it was people who could come to the university over the summer break. But we had 16 participants, 8 boys, 8 girls. They were aged between 12 and 15, comfortable in English. We tried to do things bilingually, but we had Swedish, so we had Swedish and English. And then they were randomly assorted into three working groups, so WALL-E, Baymax, and R2D2. So I said that this was a summer school research study, and I think that's really actually worth commenting on. Again, reflecting on how I as a roboticist, how I do research, how I do robotics. We were open with the students that this was, there was 2 parts to this thing that we were inviting them to. So half of it was for us. We wanted them to be co-researchers in our project. How can social robots make teenagers' group interactions better? That was actually all of the design brief we gave them. We did not say they had to be more productive. We did not say they had to be more inclusive. This is what we were hoping. But we did really just say, you need to make your group interactions better. That's the purpose of the robot. And then you'll see from the setup, basically, once we got through the initial co-design stuff, there was always one group working with the robot in the training sessions. So then in the off time, when the other two groups who weren't working with the robot, they were working on their own like robotics research projects. We were teaching them coding. We had a bunch of robots for them to practice coding skills on. So we really tried to make this like a mutually beneficial experience. And I think that's important because, of course, the stuff they were doing here is not exactly completely separate from there. And they had ideas flowing between these 2 strands that I think is important. Okay, so as I said, we only told them that we wanted to design a group robot that could help them enjoy better groups. These were the kind of pictures that we used, so I guess we kind of implied we wanted them to enjoy themselves more, but we really did not specify anything about, yeah, you need to get more answers correct, or you need to do, we just talked about better. And this is kind of how the process looked like over the 2 weeks. So we started with some typical participatory design where we ask them their thoughts and then they tell us and then we tell them our thoughts based on the literature, and you have this like negotiation, some action design, refinement, some testing. I think maybe I can show a bit more here. So yeah, we asked them about, what does it feel like to be in a good group or a bad group? When have you felt like you were enjoying a group session? When have you felt like it wasn't? How did that look like? And then we shared with them, after we'd heard their ideas, just like, what do you know about robots? Do you think that robots can help you in groups? Then we showed them some of the robotics literature that was motivating us to try and bring them on board with understanding the state of the art. Then we also got them sort of role-playing and reflecting. So we did a bunch of like role-play type activities. Putting them in groups and giving people like a prompt, both a nice prompt and a bad prompt, like you're really confident that your idea is the best one, versus be super interested in what everyone is saying, or you think the person to your right is clever and amazing. And we gave them different like modality constraints. So sometimes they had a mask on, sometimes they had to sit on their hands. But basically we were trying to get them reflecting on how can someone's group behavior, how can one group member's behavior influence how the rest of us feel? And how do you communicate in a group in a way that's multimodal? Because we knew that we were going to get them designing multimodal robot behaviors. We also did some fun role-playing where we, as the researchers, took on the role of the group assistant robot, and then the robot programmer had to sit behind us and whisper into our ear how we should influence the group. So we got them trying to think a little bit about what programming would look like in this context. And then they got to actually come up with some designs. So we did a bunch of like brainstorming. They got to actually test out the robot and then refine these designs. And then we spent one afternoon similar to the fitness instructor. So the kids themselves came up with all the dialogue for the robot. And then we implemented that in like one 12-hour coding session overnight when the kids went home, ready for them to come and play with the next day. So that's kind of how we did it in this really tight time frame. So here is the action space that resulted from all of the co-design work. So you can see they came up with, well, it's important to note two things. Most of these actions can be either joint or individual. So they can either be targeting the whole group or they can target an individual. And I'll show you some examples of that in a minute. But this is actually how it looked like to them. So this is the tablet that they were holding in the control of the sessions, and I'll show that in a minute. But things like prompt discussion, that's things like, well, maybe I just put the table up, it's easier. So things like, ask someone's opinion. So again, at the group level, you can just say like, oh, let's discuss our opinion about this. Or do you have an opinion on this matter? Insert name. The joke is only at the group level. The joke was a very important action for the kids, as I'm sure you can imagine. And I'll talk a little bit about that later. But then there's also these nonverbal things. So you can nod at a particular group member or an individual. You can look at a particular group member or individual. You have sort of reminders here, like these are what the kids wrote. So remember, teamwork divides the task and multiplies the success. Remember, we are a team. We have to cooperate. If any of you can't read the joke, it says, I wrote a song about a tortilla. Actually, it's more of a rap. So this is all things that the kids came up with. And what was maybe one interesting thing, again, just to show the fluidity of this process, we had originally imagined that all the three groups we were working with, they would share the same action space, but maybe each group would have only their utterances, right? So that they would have like a personalized experience. But actually the kids downvoted us, and when it came time to like refine the actions, they were insistent that they wanted to pool their action utterances, because they realized, of course, that makes for a more interesting experience because it would take longer to cycle through the different utterances. But that was interesting because we had kind of assumed they would take ownership over their version of the robot, but no, they preferred to share. Okay, so then this is what it looked like in terms of the training setup. I'm not going to talk so much. We tried to really replicate LEADER. So actually, in terms of the machine learning process, each child was microphoned up, and we were trying to basically learn. We thought that we didn't consult with the kids so much this time on the input space, or at least we did consult with them, but we had already decided what we were implementing from a complexity point of view. So we had a Kinect camera that was going to try and do some sort of bodily tracking about whether they were hunched over, whether they were like, backing away or close. And then each kid was microphoned up. So basically we thought that the interesting thing was, what's the speaking participation like across the three group members? But yeah, we didn't push the autonomy so hard. We did test it at the end, but yeah, we can talk about it afterwards if you're interested, because it wasn't as good as the robot fitness coach, put it that way. So this is what it looked like. So these three are working on a subjective, like open-ended task. So the specific one they're working on here is, here's like 10 jobs and here's 20 robots. Which of these robots do you think is best for this job? So there was no correctness, or we tried to come up with tasks that were completely subjective, that would generate discussion and that they would have to come to some collaborative answer on. And then the robot is obviously trying to help them with that. Then we have the robot controller or the robot teacher. So he, in this one, is holding the tablet with the interface that we had designed on their behalf, basically based on the actions that they said. So his job is to watch what's happening here and then tell the robot what to do accordingly. And then again, every time he does that, we take a snapshot and you've got your training data. And then we also had a fifth group member who was in what we called a sort of group witness or a group observer role. So this was based on some other work on participatory design of robots with teens in the US, where they had said it's quite nice to have this observer who can also be keeping track on how he understands the group dynamics to be going, so that they can afterwards kind of cross-check. Like, okay, the robot teacher has an idea of what he thinks is happening, and then you have this sort of more impartial witness to the interaction. Yeah, so this is how it looked. Okay, so again, I have some nice action graphs, I guess, about like normalized actions across the groups and how these looked a bit different. So again, we can argue about whether this is the best way to show this, but I think it at least highlights some of the differences between the groups. So R2-D2, this was the group that I was working with, they were already very cohesive. So the groups, they didn't know each other. It was completely random how they were assigned, other than we tried to mix boys and girls at a roughly equal ratio. The R2-D2 group generally worked very well together, and I don't think they really needed the robot. And that's something that they will also, I will show some of the excerpts of what they said. So yeah, for them, not super necessary, and you can kind of see, I don't know, there's quite some disagree actions. Yeah, we can talk about that in a bit. The R2-D2 group, sorry, not R2-D2, the Baymax group, they very much used the robot in a teacher-like manner. So actually how well they worked as a group really depended on the specific constellation, because these roles we rotated out. So this was like a 45-minute session, and they swapped robot controller after 15 minutes, I think, in order to all get a turn during a session. And how well the Baymax group worked together really varied based on who was in the driving seat and who was in the group members. And Wall-E was a mess. They did not work well together. I don't think they really liked each other. It was really a rough pairing of a rough combination of kids that didn't work super well. And you see some of that reflected in the actions. I mean, again, this is really hard data to try to figure out the best way to look at it, to understand what was happening. We videoed the interactions, and there's a load of analyses I think we still need to go back and do. But in general, you can see just with the focus action, so as I said, the R2-D2 group maybe didn't need the focus action so much because they really, yeah, they kind of worked well already, whereas Baymax and Wall-E needed a little bit more. However, the joke action, I mean, R2-D2 also leveraged the joke action, not as much as Wall-E, who, as I said, this was a bit of a chaotic group. One might suspect that the Wall-E group overused the joke. But what's interesting in the Baymax is that they did not use the joke so much, but they did use the focus a lot. And I think that replicates that. The bottom group, who was working well, they used the robot as a way to inject a bit of fun, a bit of liveliness. The top group, they were really using the robot as like a rule keeper. And then Wall-E was just all over the place, honestly. We can also look a little bit at how the robot was like leveraged differently towards different kids. So this is two members within the chaotic Wall-E group. So W2 was very shy, a smaller girl than most of her peers, and she was very quiet. And you can see that the robot actions that were targeted at her, a lot of them were either asking, so trying to get her to talk about her opinion more. The ask was like, please tell me more, what do you think? Or the look at, right? So like non-verbally having the robot look at her and try to prompt her engagement. W4, on the other hand, was very excitable, very extroverted, and he has actions that are more like, you know, agreeing and disagreeing. But one has to wonder whether the look at here, given the amount of agreeing and disagreeing and the kind of reminding him, maybe the look at was like, okay, you've spoken a lot, maybe you don't need to speak so much more. Whereas with W2, I think it was more like looking at her to try and prompt some engagement. But I just think it's just more to raise, like, this is really complex dynamics that we see. We see kids being thoughtful about how they're using the robot to target particular peers. And then what's even more interesting, and as I said, like this was so exploratory, there's so many different things we could probe here. But in this case, the very sort of shy, extroverted girl, W2, the way that she was behaving in the group didn't necessarily, or in some ways it did and didn't translate into the way that she was a robot controller. So you can see she used the look at action a lot. So she was maybe still using like nonverbal cues, but she also wasn't afraid to ask, to agree with people, to, I don't know, joke a little bit, to praise people. So then you get into interesting questions about whether the robot allows some sort of, I don't know, getting out of your head a little bit, maybe allows you to have some sort of distance that maybe reduces your inhibition a little bit if you're shy. But this is, it's an open question. Okay, and then at the very end of the study, we told them that we're about to take the robot away. And we asked them, before we took it away, we did some little focus group. Okay, so we're about to take the robot away. Before we do, maybe you want to share your ideas. How do you feel about the fact we're taking it away? So Baymax said, yep, it's helpful, but it's not so helpful anymore. R2D2 also said it's not so helpful just because we got to know each other. Once we took it away, Baymax realized maybe they needed it more than they thought. So they commented about, actually, no, people lost focus and started talking, and then we didn't get very far. R2D2 was a bit more as expected. So as I said, we observed them also to be working very well together. So they said things like, oh, it wasn't a worse discussion, but it's more fun when the robot is there, you get more energy. And yeah, people in Worley were very, the ones in Worley that wanted to work well were very sad to lose the robot. I just like this quote, like, yeah, you know who you are. They kept arguing. The robot could have stopped that. I had to. The robot could have said focus or something to make them stop, but there was no robot, so I had to try to stop them, and it didn't work. So we really saw very different dynamics in these groups. And so our kind of takeaway was that we saw the robot kind of, the need for the robot and the way the kids used the robot on a sort of spectrum. So R2D2, they really didn't need the robot, but they still somehow enjoyed it, right? It seemed to add to their experience. For the Baymax, the robot really played a key role in helping the group work together. And for Wally, the use or necessity of the robot really varied based on whatever combination of who was controlling and who wasn't. So our pitch from the end of this was basically that if we want to use robots for this kind of group assistance type work, whether that's trying to equalize participation, whether that's trying to make a more inclusive environment, the robot really needs to be adaptive to be able to move dynamically through these roles, both within groups as the group sort of evolves, but also between groups, it's probably likely to be different. The other kind of thing that we sort of took away, given that this was such an exploratory work, was we think like this joke action, this is what we were nervous of, right? They're going to make it say something silly and then they're going to spam that action. I don't think that's the case, actually. I think they were pretty sensible about it. And even for the group who was already working together really well, I think that playful behavior was perhaps important for them. And I think that's the kind of behavior that we would have probably missed if we had just tried to leverage psychology literature or social science literature and thought more about the robot as a real authority figure and less of a peer figure. We also did a bunch of like qualitative debriefing with the kids. They were very clear that it was important for them that they were involved in this process. Like, it added so much, I think, in terms of the way they engaged with the robot, that they had some co-ownership. They had some sort of, it had some peer authority, let's say. they also did raise the idea that maybe it needs to be, especially in the Worley group, they were like, yeah, maybe we could work together. Maybe we need some help from you researchers as well. But in general, they were really big on this process. It meant something to them. And we did do some stuff trying to probe a little bit whether they understood machine learning more by the end of the study, whether they understood the risks and opportunities more. But I'm not making super strong claims because we also had this like educational part that went alongside it. But I guess I feel like this is a useful way that we might think about involving young people in robotics design, but also in like educating them about how these systems work. And then maybe the final thing I just want to quickly say from this study is like, we also, our hypothesis was, yeah, by the end of the 2 weeks, their group working skills will skyrocket because we're doing all these activities about group working skills. Actually, the self-report measure significantly decreased. But if you look at the statements that the self-report measure includes, so things like, oh yeah, I ignore my teammates when they tell me to stop doing something, and like I would certainly do that or I would not. Our suggestion or our hypothesis is maybe, okay, do you know what? They actually realized how their group working was good or bad or not over these 2 weeks. And so this decrease in self-reported group working skills is probably an increase in self-understanding, having been given that like third-party view or that third-person view. Okay, so that was kind of brings me to where I am now, assistant professor at Uppsala. This was the last thing I did in my postdoc at KTH. So now one of the things we want to do next is still down this line of like, am I really bothered about creating autonomous robots anymore? Or at least I'm more interested in the educational element of this process. So what would it look like to redesign this kind of setup on the assumption that one of the things we're really interested in doing is teaching the robot controller some collaboration skills, or that this is a mechanism through which he might improve and acquire new collaboration skills. And I just finished a guest fellowship at Bochum, where I've been working with some educational psychologists there to think about this. And then I would just flag, in case any of you are interested and want to talk about this after, so this kind of participatory automation is one big strand of what I do. I also do a lot at the moment around, let's say, feminist human-robot interaction. I'm interested in sort of social relationships around robots, recognizing power imbalances, asking questions like who gets to be involved in robot design and deployment. That's not so dissimilar to what I just presented. But I'm really, really interested in how robots influence our social and moral norms. So in this case, it was really focused at the group level. How can robots increase inclusivity in groups, let's say? But also, what does it mean to have gendered robots? What does it mean to have robots that are like stupid when you abuse them and they don't respond properly? And what does that say about what it means to be a woman in technology? I mean, this is another strand of what I do. But under this umbrella, I would also say, yeah, reflecting on how we do robotics. Like, what does it look like to design robots for basic psychological needs fulfillment rather than just performance and efficiency, which tends to be the measures that come up in robotics. But I flag this just in case any of you want to talk afterwards. And with that, I will say thank you for listening.
Yeah, thank you very much. Do we have any questions? Okay.
So thank you for the presentation. Can you show us some recordings from how that actually worked in this interaction? That would be very helpful to see, because often it's the subtle things that really change interaction a lot.
I don't have any with me. I could maybe see if we can do this offline afterwards. Yeah.
That was really exciting. Thank you. To that question, I guess, I wondered, because you mentioned the safety aspect as well in the gym, and you mentioned one of the girls also, she didn't like the robot. Yeah. And I wondered why that is, or did she give reasons for that? And I wondered if you asked them for safety, like how safe they felt with the robot versus a real human, and if the human wasn't there. Because, I mean, robots have some kind of agency, but we still realize they're not real people, and maybe they might not feel safe. I just wondered if you have data on that.
Yeah, okay, so it was in the gym robot where one of the women participants didn't like the robot. I think she came just, I don't know, didn't want to let me down or something. But I mean, she could have stopped, right? I mean, and we made this clear repeatedly that she could have stopped. Yeah, we have some, we tend to, I mean, like, okay, human-robot interaction as a field is like 10 years old, and we still have not decided what our standardized measures are. So we have some measures that tend to probe around like, okay, how is do you feel comfortable with the robot? But in this case, in the robot fitness coach instructor case, we didn't really have a human-only condition to compare to. And I'm not really sure what a good control would look like for that. So I guess we could have had people who were working out with the podcast, because that's really how this is delivered at the moment. It's unusual to do this sort of relatively simple program with a human involvement at all. But I've done a lot of other work on testing in slightly more artificial lab studies where people come in and work out with the robot for a single session. And I probed them on things, because one of my studies, halfway through my PhD, one of my supervisors was like, yeah, this is really unethical. Like, I'm not sure about using these human-like behaviors to try to motivate people to exercise. And so actually we did some qualitative work there and asked them like, okay, the robot today asked how you were feeling and made the effort to respond appropriately. So if you said you felt bad, the robot would be, oh no, I'm sorry to hear that. I really hope we can change that. And we probed people on whether they thought this was genuine, and this was the word that we used. Do you think this is genuine? And did they think it was deceptive? And if yes or no on the deceptive question, did they think it was acceptable? And this is where things get really complicated, because for most people, in this, I should have put some slides on this to show better, but basically, we found that the control robot that did not employ anything like more anthropomorphic, they already found that almost equally as deceptive as the robot that was like, I'm so happy to see you, and employed all of these emotion cues. Now, people didn't seem to be any more deceived, let's say. They did not think they were being deceived, but their behavior massively changed for that robot. So the robot that was employing these human-like persuasive cues, they worked out more for that robot, even though rationally they were like, yeah, no, this is all false, I understand. And then interestingly, the questions on deception and, on genuineness were also all over the place. And the comments were like, yeah, I gave it a 5 out of 5 on genuineness because, yeah, the robot doesn't care, but the person who programmed it cares, and that's what matters, right? Like, if my therapist has sent me this robot, then really it's just a manifestation of the therapist's care. I'm like, oh, okay, I don't know how I'm going to model this, but whereas others who are like, no, it's completely genuine, completely not genuine, they still gave it 5 out of 5 for acceptability, because they were like, yeah, but if you're going to use a robot for this kind of application, then it needs to engage in this kind of social script that we expect. So for them, it was like completely deceptive, but completely acceptable. And then we had people in the middle. So I think what's really difficult, and I think that's why I've become more interested in designing autonomous is fine, interesting, whatever. And it's a hard AI problem, and that's interesting. But really the complexity of this human-robot teaming, how that could operate in practice, how people conceptualize the robot as a sort of agent or as a proxy for someone else, and who that someone else is. Maybe you're an Apple user versus an Android user, and if the robot came from Apple versus Android, you would have feelings about that. This is all sort of not really well understood yet, how we can delineate those things. But yeah, I don't have any sort of strong evidence, more things like when they talk about the robot, how do they then reflect on whether they would prefer which bits with a person? Yeah.
So in the group behavior of the kids, if I understood you right, every kid would sometimes control the robot and sometimes be in the group.
Exactly.
How does the detaching work? Because in a way, the group, they now are missing that one person, and they know that person is sitting in the back and is now controlling the robot. So they know exactly the robot is doing what you are doing at the back, and then later that same kid is within the group. Does just the very fact that there is a bunch of plastic sitting in front of them totally detach from the person in the back? And the detachment also works for the person in the back. Does the person in the back feel like, now I can do things that I couldn't do if I was there? You talked about one example where W4 was more assertive. But in general, is there sort of a projection or more of a detachment there?
Yeah, I think so. I don't know, and I don't think we've analyzed the data deeply enough to be able to say something concrete, but we did ask the kids outright about this in the debriefs at the end. So we asked them, okay, to what extent do you feel like you were interacting with now the robot, or were you acting with whoever was controlling it? Most of them seemed to be quite happy and confident and comfortable playing along with the robot until it did something weird. When it did something weird, they might break the fourth wall, so to say, and look at the controller. This is what we observed. But when the robot did everything that I guess they were expecting it to do, I really think they engaged with it. And they would say things like, yeah, thanks now. They wouldn't say like, thanks to the person behind. And also, they knew that the training actions, so they knew from the beginning that our hope was to make the robot autonomous based on collecting all of the training data. So there was also this like, let's say social pressure, right? Because they didn't want to be the one to screw up the robot teaching. And I think that also kept some of them more in line than some others. Yeah, go ahead. Yeah. So I mean, this was part of a dialogue all the time. And my good feeling is that for them, consciously, they knew it was their friend, but when they were lost into the group task, I think they engaged with it quite automatically. And we see that in adults too. This kind of goes back to what I was just saying. I think most of us, we all would say rationally we understand the robot is a artificial, often teleoperated agent, but actually our sort of systems one style thinking response is to engage with it as like as an agent. And I think that was what was going on there as well. But I think what's so interesting is that's not how you normally do things in human-robot interaction. You normally have the wizard or the puppeteer really hidden away, and you really try to pretend that the robot is this completely autonomous agent. The argument being, eventually it's going to be autonomous, and so we want to understand this impact. But opening up this kind of Pandora's box, like, why do we want to do that? Actually added a lot to the robot's credibility that there was this person involved. And I think they engaged in good faith with the idea that like it was controlled by their friend for them in order to help them. And they were all playing their role in training it, so to say. Yeah, I don't know. It's quite complicated even to post-hoc rationalize.
As a follow-up, you said that this was pre-LLM times.
Yeah.
Do you think it would change if the robot is more sort of fluent in language and more full of fantasy and creating a more person?
Yeah, this is something that one of my PhD students now is working on a lot. I think like how I would love to plug an LLM into this would be to just create new utterances, but I would want that still to be very constrained by like the kids' personalities. So we are playing now with, okay, can we ask LLM, can we feed an LLM like the big 5 scores of a particular character and have the robot generate these utterances that would match? That is how I imagine doing this. I only want to use the LLM as a way to generate like 1,000 different ways of saying good job that is contextually appropriate. How well or not that works so far, I'm not sure, but I'm really convinced about the fact that the children involved need to regain the authorship, or retain like the sense of authorship as much as the authorship itself. Because I think that was so crucial here, this sense that like this is our robot with our actions. Like I wouldn't want to introduce LLMs in a way that would take away any of that feeling of like investment in the system. Yeah.
Okay, then I think this is the end of this talk today. Thank you very much, Katie. And also, so the PhDs would like to spend more time with the guests, I heard. So Katie will be available for coffee now, or also for other researchers. And we are also planning some social learning experiments with robots as part of a future collaboration. So if you're interested in that, you're very welcome to talk to me or Katie. Thank you.